So as I said, we will be solving this problem using a level order traversal or BFS, and at each level, level 1, level 2, and level 3, we will append the last node to our answer. So basically on this level, my only value is 1, so I'll append that. And the last value in my second level, which is this, is 3, so I'll append that. And on my third level is last value is 4, so I'll append that. So that's what my answer will be for the for example 1. Now how are we going to do it? Let me just write the pseudo code for you guys, and let's go over how actually we're going to solve it. So I'll keep the answer array as empty. So we know in level order traversal or BFS, we basically use a queue, and that queue initially will contain our root node. Now I will start a while loop. In my while loop, I will basically check if there is any value in my queue. If there is, then I want to take the snapshot of this queue, and I will basically assign an empty array to this queue now, and I will process this queue. But before I process that, I will append the last node to basically my answer. This is here where I will basically append the last node's value, okay, into my answer. And then for node in queue, I will basically process all the nodes in my small queue and append if all these nodes have left and right child. So basically I'll have conditions if there are left and right node of this node, then I will append those to my main queue. So let me just write it. So if node dot left, then append it to queue dot, so we can do that later. And if node dot right, then also we can just append and that's it. And in the answer we'll just return answer. Yes, okay. So this is it. This is the approach. You guys already know how to write a breadth first search. It's just little different in terms of returning the answer, because here it's basically taking the rightest or the last node of our one level at any point and just appending it to my answer. So initially let's create the answer as empty array, and then my queue will be basically containing the root. Now while this queue is non-empty, I wanna take this snapshot of all the values from queue to small queue, and my bigger queue will be just empty queue now, because I want to process one level by level, and one level is just at a given point I want to process, so that at given level I will basically append the last element. So queue's last element dot value. I hope this syntax is correct. Now I want to process all the nodes in my small queue. So for node in queue, I want to append all the child left and right to my big queue. So if node dot left, that means what? They need to be processed on the next level. So like now we are starting at 1, which is basically root. So I want to check if it has left child, which it does, then we're going to append 2 and 3 to our queue. and then in the next level we will be processing 2 and 3, and 3 given 3 will be added to our answer, just like 1 is added to our answer right now. So we can add that to our queue dot append, and not dot left. Same way, the same thing we'll do on the right side. Right child, if it exists, let's add it to our main queue. Okay, and that's it. Then we can finally return the answer, and let's zoom out and try to run it. Yes, of course, we just want to check, have the condition. If root is none, then what was the thing that we're returning? Empty. Return empty list, and let's run it again. Okay, this is good, and let's try to submit it. Awesome. Okay, let's write down the time complexity. Time complexity would be big of n, because n is the number of nodes we are processing here. Chada. And space complexity will also be big of n, and the reason is we are basically adding and all the nodes to my queue at a point. There might be a case where we might have to add all of them to our queue. Okay, let's go back to our AlgoYogi and mark this problem solved, and later we'll be solving more problems. But before we go there, please like, share, subscribe, and start using AlgoYogi to track your problems and start preparing in a better way for your coding interviews. And we have the target of completing 500 problems on AlgoYogi, which are the essential problems that we need to solve, covering all the DSA and all the algorithms. Once you are done with those, you can crush any fucking interview. Okay, see you guys in the next video. Love you. Bye bye.